Let's move on to our next example. A 65-kilogram goat is sliding down a hill with an angle of 27 degrees to the horizontal with some constant velocity. Okay, so it does offer some important information. 65-kilogram goat sliding down a hill with an angle of 27 degrees with some constant velocity. It says draw an appropriate free body diagram with just weight, friction, and the normal force. It is only asking you to draw three forces. You will only draw three forces. Do not do more work than they are asking you to do. If they say draw three, just draw three. Not four, not five, three. Okay? So let's draw free body diagram. We know that the force of gravity, which we also call weight, okay, so you're more than welcome to put a W, an FG there, or a W. Okay, that's fine, either one, but just for the sake, I prefer to put FG. But like I said, you are more than welcome to put W there. We know that the normal force goes like this. You should see a 90-degree angle happen right here. Okay? If you can't justify that, that means you bent your normal force, and that's going to be considered wrong. And then you have a force of friction that pulls, or excuse me, is going to be pointed up, but that really means the block is sliding down, and that means that the force of friction vector should be in the opposite direction of motion. Okay, so this is how you would get full credit right here. Notice that I have a dot right in the middle. FG is perfectly straight down. My normal force makes a 90-degree angle, and my force of friction, it's parallel to the surface, but also it goes through like the middle of the block. Notice how the frictional force and the normal force go through the middle of the block. Okay, so please keep that in mind when drawing your free body diagrams. All right, if you go into the second part, still the same information up here, but it says to now draw the perpendicular and parallel components of gravity on your previous free body diagram. So again, I'll draw it in different colors. We know that the force of gravity parallel is the one who pulls down the slope, and then we know that the force of gravity perpendicular is one that pulls into the surface, and so it's equal and opposite that of the normal force. Okay, so that's how you would draw them on your free body diagram. So again, I'll write that right here. FG pulls into the surface of the inclined plane, and then the force of gravity parallel pulls down the slope. Okay? So now the question's saying, using the information, right, find the goat's weight. So we have this value of 65 kilograms, 27 degrees. Okay, it's at constant velocity. So if we go back to our free body diagram, we always know that the force of gravity perpendicular is always equal to the normal force. Oh, excuse me, wrong thing. In order to find weight, just like any other time before, we would say we would have a mass and we would multiply by the acceleration due to gravity of the planet, right? So we write out our givens. We know our mass is 65 kilograms. We know that theta is 27 degrees. Our unknown is Fg. We don't know what that is, but if you went on your reference table, you would find out what you can do in order to find Fg. So we know the formula to be Fg equals mg. Again, on your reference table, you'll see it as the following. Okay, that's okay. All you have to do is do some cross multiplication, and then that's how you get that form. Okay, so now let's substitute. Fg equals 65 kilograms. We are on this planet of Earth. We use 9.81 meters per second squared. If you multiply that, you will get a force of gravity, or a weight value, of the following: 637.65 newtons. Okay, this value is going to be very important for us in the next two questions. All right, so now if we move on to the next part, it says, find the normal force acting on the goat. Well, we know that the normal force is always equal to the force of gravity, as we see right here. Okay, we always know that to be true on an inclined plane. However, if we know that Fn equals Fg perpendicular, in order to even get Fg perpendicular, we need to have a force of gravity. Oh, but would you look at that? the force of gravity that we got from this problem is going to be useful to us. So we say that the force of gravity equals 637.65 newtons. My theta is 27 degrees. My unknown, right, is the normal force. We don't know what that is, but we said the relationship is that the normal force is equal to the force of gravity perpendicular, which is always going to be true no matter what on an inclined plane, is equal to the force of gravity cosine theta, okay? So we say Fn equals Fg perpendicular equals 637.65 newtons times the cosine of 27 degrees. If you plug that in, you will see that your normal force is equal to the value of 568.2 newtons. Okay? Again, we want to make sure our calculators are set on degree mode. All right, so that's how you would get your normal force, because this relationship is always true on an inclined plane. And finally, you have find the force of friction of the goat. So again, we know that if my object is moving at a constant velocity, if we go back all the way to our free body diagram, we can see the following. The force of friction equals the force of gravity per parallel, So we say the force of friction equals Fg parallel. So our givens, we know that that force of gravity is going to be very important. So we say my force of gravity is equal to 637.65. That value clearly is going to be useful. Theta is 27 degrees. My unknown is the force of friction. My equation, if it is sliding down the slope, right? So that means it's Fg parallel. Use sine, okay? Right? Sliding down the slope, use sine, SSS, okay? So I'm just going to put SSS, sine, slides, slope, okay? Just keep that in mind. So we say the frictional force is equal to Fg parallel, which is equal to Fg sine theta. Okay, I'm going to keep emphasizing that. I'm going to sound like a snake because I hope it helps you remember. Okay, so now we're just going to substitute 637.65 newtons times the sine of 27 degrees. If you plug this into your calculator, you will get the following. And that is 289.5 newtons. Okay, again, this relationship is only true when you're at CV, right, constant velocity on an inclined plane. So just keep that in mind.